I'm going to explain how I designed this air jet powered car that's powered by the air coming out of a balloon to make science more interesting in third grade. My daughter teaches science in third grade, and I wanted to make some of these cars so she could teach about energy and action-reaction and conservation of momentum. So I looked on the internet first to see what kind of cars I could find, and I found this one. I thought, wow, that's an interesting car. Look at that. It's a hot rod balloon rocket car that I found on printables.com. It looked neat, and so I started printing it, and I didn't realize how big it was. It weighs 70 grams. I decided that's way too big to be powered by a balloon, and I wanted to make a lot of these, so I didn't want to use up a lot of filament and the 3D printer. This was just too heavy. I didn't even print the wheels. Then I looked around some more, and I found from the Limitless Steam Lab, I found this design. I redesigned it because the wheels were different. And so the way I made these wheels is I designed my own wheels that look like this. And I had some dowel, a little dowel. And you could push the dowel into the wheels and push it through the car body, and then push the wheel on the other side. And you had the two wheels and the axle that I used in the car. So this could be 3D printed, but you needed the dowels. It has a nice place to put the balloon. It has a nice outlet in the back that you can blow up the balloon with. And inside there's kind of a nozzle, a vortex, that makes the air go through a smaller region and maybe go a little faster. But it has a fairly large tube for the air to go out, and so the air will come out pretty fast. So I said, let's try this one out. Although it's a little heavy, I'll see how it works. So you put a balloon on the top, and you'll blow it up with 3 puffs. And then I'll put my thumb over the back. So there it is. It's ready to go. 1, 2, 3. You see the air comes up pretty fast. It doesn't go very far. It goes a little bit, but because the air comes out so fast and it pushes it around, sometimes it doesn't go straight, sometimes it spins around, and it doesn't go very far. So I said, well, let me design that one's too heavy. And at first I thought I'd just cut away from some of the weight from that one. But then I decided to design one from scratch. And so here's a car that I designed. It has a flat body with some holes in it to use less weight. It has a nice place to attach the balloon. Has a nozzle coming out the back. Same wheels. That goes well. And I tried to experiment with the size of the tube coming out of it. Now the tube is the same size as the outlet as it is from where the balloon comes in. So there's less turbulence for the air when it comes out of the balloon. So let's try this one. The diameter of the tube for this one is 12 millimeters. The diameter of the tube on the original one from the Limitless Steam Lab was 14 millimeters. So it's a little bit smaller than the Limitless Steam Lab. We're trying to make it maybe last longer. Okay, let's try this one. I'll puff it up. There we go. 3 puffs. 1, 2, 3. So that comes out really fast too, and sometimes it spins around. So it doesn't go that much farther than the other car, just because it comes out too fast. So then I decided I'll go to an extreme. I'll make a really tiny nozzle, really tiny tube coming out of the balloon. It was only 3 millimeters. But I found out that when you print this car in a 3D printer, the tube is so the curves are so tight that it doesn't 3D print it. It makes it, the tube isn't hollow. The tube is filled up with the filament. So that didn't work. So you couldn't even try it out because it wasn't a tube. It was just a solid column. And I said, well, let me try 7 millimeters diameter. So it's this one. You can see that the tube is smaller than the other one. And I've also changed the design a little bit. You can see that I made the tube extend out past the end of the car. You can see that here. That makes it easier to blow it up. I also hollowed out the back of it a little bit. So now there's a scallop that goes down in the back to make it weigh a little bit less. Let's try this design out. So the tube is a little smaller. Put the balloon on and blow it up. Okay, 3 puffs. And 1, 2, 3. That goes pretty good. But again, the air comes out pretty fast. But it went nice and straight. Went pretty good. That wasn't bad. So I decided to do one more trial, and that was this. So in this one, the diameter of the tube coming out, the exhaust, is 5 millimeters. And I made one more change. Instead of using dowels for the wheels, I printed the wheels in 2 parts. One wheel was printed with the axle. You can see the axle there. One wheel was just printed plain, and you can put the axle through the body and just snap the other wheel on. It would press fit, and it would just press like that. So now the axle is smooth plastic, and you can see that spins much better than the dowel. So that was better, and the exhaust is smaller. Let's see how that works. Put the balloon on again. The balloon. And you see it's pretty sturdy. You can push the balloon on pretty tight. I'll blow this up. Okay. 1, 2. Oops. There we go. 1, 2, 3. You can see it starts slowly and keeps going, and even when it gets to the end of the table, it still has lots of air left. This design works very well. And on a flat surface, the air comes out sufficiently to make it move, and it lasts for a long time. It can go up to 40 feet. So that's the design. Here's the design that I've made. It weighs only 11 or 12, I'm sorry, it weighs about 24, 25 grams. And it's easy to print. The whole thing gets print just with PLA on a printer. You don't need anything special. And you can print 10 of these for a class to try. And they're very sturdy. And they can do things like measure how far it goes depending on how many puffs you put in it. And you can describe different things like potential energy and kinetic energy. You blow the balloon up, and the balloon has potential energy. And when you let the car go, it turns that potential energy into kinetic energy. You can talk about action-reaction, and the air jets out the back of the car. It makes the car go forward. And you can talk about conservation of momentum. When the momentum of the air blowing out and the movement of it causes the car to go forward with the same momentum, and so if the car is smaller, it'll go forward faster. And the energy in that balloon gets converted into faster speeds for the car as the car is less weight. I'll post the design for this so you could print these cars yourself and use them to teach in elementary school. Thank you.